All right, so we are looking at probability involving permutations and combinations. So it's a good review, basically, of some permutation and combination questions. It involves probability, right? So the likelihood that this event will occur. So sometimes you might use your your permutations or combinations notation. Sometimes you might think about it just in actually doing that actual experiment yourself. So it says the word counted has been spelled using Scrabble tiles. 2 tiles are randomly chosen, one at a time, and placed in the order in which they are chosen. Determine the probability that the tiles are C and then O. So order matters then. So this is your word, right? There's only one C and one O. So there's only one way to get C and O, right? So we want to get the probability. Okay, so probability. Oh, just give me a sec. Still learning. Okay, so CO. There's one way to get C and one way to get O, right? Because there's just one of each. So probability will be 1 over all the ways, all the arrangements of any 2 letters, right? Because it says 2 tiles are randomly chosen. So what are all the possible 2-letter arrangements of the letters in counted? So that would be, so count up. 1, 2, 3, 4, 5, 6, 7. So we have 7, and we're arranging 2 of them. Okay, so that would be the probability. What is 7p2? 7 times 6, right, is 42. Okay, so the probability would be 1 out of 42. Another way you can think about it is think about actually doing that experiment where you have 6 tiles and you put them, 7 tiles, and you put them in a box and you randomly choose. Okay, what's the probability that you get a C? Well, there's 1 C out of 7 letters in that box. Okay, then we need to get an O. So if we've chosen a C, there is then 1 O out of 6 remaining letters or tiles, Scrabble tiles. So if we do that, we get 1 out of 42. Okay, so either, you get the same answer. Okay? Both being vowels. Let's see, just give me a second. That's not what I want. Okay. It detects everything, so. All right. Both vowels. So take a look. We have 3 vowels. So arrangements of the 3 vowels. There's 2 out of the 3 vowels. So we're only choosing 2 tiles. Okay, and they both have to be vowels. So that's the total arrangements of any 2. Any 2 vowels out of the total number of arrangements of any 2 letters. So that's going to be, 6 out of 42, which is 1, 7.
Wasn't that, because I know the way I read it was C2 times 2 factorial over the thing times 2 factorial, because I think that would just be the same thing. 2 factorials cancel out.
Yep. Okay, so, or you could say, okay, we have 3 vowels. We want the first vowel, so it's 1 out of 3. then we want another val out of the remaining 2. Okay, and no, what did I just do? We want both vowels. So 1, 2, 3. Gotta think about that, doing it the other way. Yeah, you'd have to then multiply through. I'll have to come back to the other way for doing that. Yeah. Yeah, thank you. 3 choices. It's been a long break. 3 choices out of 7. So there's 3 vowels out of 7. You've chosen 1, so there's 2 vowels out of 6. And then there's 1 7. Thank you, Adam. You're away. Okay. Okay, listening. Next one is committees and subcommittees. So likely it's a combinatorics question. Combinations question. So the athletic council decides to form a subcommittee of 7 council members to look at how funds raised should be spent on sports activities. Total of 15 members, 9 males, 6 females. What is the probability that the subcommittee will consist of exactly 3 females? Just want to be careful in case there's a question that says there's got to be a president, vice president, secretary, that kind of thing. Because that does matter what order, but this doesn't, right? So we want probability of 3 females. Okay, so what is, we've got 6 and 6 females to choose 3. We want exactly 3 females, and the subcommittee has to have 7 people in it. Total of 15. Okay, so that means you've got exactly 3 females. The rest have to be males. Okay, so that means we're going to choose 4 out of the 9 males. Okay, so that's to get your particular group. We want the probability that that will happen. So we need to divide by the total number of 7-member groups. So 15 choose 7. You can calculate it. I'm just going to leave it. Okay. Any questions on that one? Okay. Next one, bag of marbles containing 5 red, 3 green, and 6 blue. Child grabs 3 marbles from the bag. Determine the probability that exactly 2 are blue. Okay. So there's 6 blue to start. So 6 blue, and we're choosing 2 of them. That means the 3rd marble can't be blue. So we're choosing 1 more marble out of the 8 that are not blue. And then in total there's 14 marbles. So the probability is out of 14 choose 3. Okay. Let's actually calculate this one. Actually, that's going to be 6 times 5, 3 times 5 is 15 times 8 over little less than a third. Okay, next one, at least one is blue. So you can have 1 blue, 2 blue, 3 blue. Okay? Or you can go, normally you would go, well, using the complement, total minus 0 blue over the total probability. So really, what is the total probability of an event occurring? Or the maximum that you can have in probability? That would be 1, right? So probability of at least 1 blue is equal to 1 minus the probability of no blue. Okay?
Yeah. Yeah, for a long period, that works. You have an entire unit of it.
In December, yeah. Okay. Well, not probability, but we had the complement, right? So if you're choosing 3 marbles and you have to have at least 1 blue, right? So that would be 1 blue plus the number of groups that have 2 blue plus the number of groups that have 3 blue. Okay? So that's the same as the total number of possible groups of 3 minus the groups that have no blue. Remember, it's called the complement. So in probability, because really, if we're just doing the number of these, then it would be the total minus no divided by the total, right? So total minus no. Oh, what's the delay?
Maybe the Wi-Fi slow.
Okay, so total minus no, you know your fractions, total over total is 1, minus none over the total is the probability of no blue. Okay, so no blue means it's got to be red or green, right? So that's going to be 8, choosing 3 of them, over the total, which is, what do we say, 14, choose 3. Okay, and maybe calculate the actual number. I think 365. Okay, next one. Okay, so first is red, second is green, third is blue. Okay, so order matters in that sense. Okay, so I'm just not gonna write it all out again. Okay, there are 5 red. Now, if you use P for order, that's fine. Okay, using C here, it has the same value, right? So 5P1 is the same as 5C1. So if you did it either one, you would still get the same value. Then first is red, second is green. There's 3 green. and then there are 6 blue. Okay? And then the number of permutations, okay, because it has to be, we have to check the order. It doesn't just say has to have a red, blue, and green. That's the next question. This, the order matters. So now that's 14P3. So 5 times 3 times 6 over 14. Okay, next one. One is red, one is green, one is blue. Okay? So the order doesn't matter. Now, saying that, so you could use P's for this, or I'm going to use C because order doesn't matter. So I'm going to use 5C 1. Okay? And then order doesn't matter, right? We just need to know those groups. So 14C3. I'm not sure why it's so slow. Okay?
Oh my God.
Oh my God, I've got to figure out how to lock that out. Okay? So it's still going to be 5 times 3 times 6. 14C3, we already did that, 364.
By the way, I heard you saying no, it'll go to 69. That's how much.
Okay?
Yeah.
Just in general, when you think about it, we should have a higher probability out of 3 marbles to have in your group of 3, 1 of each. Should that be a higher probability than to have order of 1 red, second one green, third one blue?
Yeah.
Higher probability, right? And it is. So kind of try to do some logical thinking. Does that make sense? If both of these questions were on a test, for example, does it make sense that there's a higher probability?
I find this there's a lot of fun. You really got to think it through to see this makes sense.
Sorry, this goes a little lower. This is made for Ms. McKay because it goes low.
You just make a joke. You just insult your phone. Wow, that takes courage.
Not really. Okay, so next one. So city council consists of 9 men and 6 women. 3 representatives are chosen at random to form an environmental subcommittee. What is the probability that Mayor Jim M. and 2 women are chosen? Okay, so
Probability, Jim plus 2 women.
okay, so there's just one Mayor Jim. There's not going to be more than one Mayor Jim. Okay, same person.
So 1, choose 1. And then 6, choose 2.
There's 3 people in the group.
In total, 9 plus 6 is 15. Choose 3.
You can figure that out. I'm going to leave it just in combination notation. Okay. Okay, I know you haven't seen each other for a long time. I'm trying to catch up. Can you just be quiet while I'm talking a little bit? Then, what's the probability that 2 women are chosen if Mayor Jim must be on the committee? So in terms of actual notation, we talked a little bit, or you were kind of on your own a little bit in Math 20 about dependent probability or conditional probability.
Notation will be probability that 2 women given Mayor Jim.
Do you remember that notation a little bit? You'll review it for the in HL in Math 35 because you'll need it more than the SLs. Okay.
And for this one, it's actually not too bad.
So
you basically just see like, okay, Jim's on the council, now it's like.
Yeah, that's what we do in this case. We don't have to do a formula or anything.
Yeah.
Okay. So this says Mayor Jim must be on it, right? And so the beginning part is going to be the numerator is going to be the same. What's going to be different is the denominator because this says Mayor Jim must be on it. So that means really out of the 15 people, we have 14 left that we have to choose 2 people, right? We have one, you can put 1C1 for Mayor Jim, and then 14 C2 would be all the other groupings of 2 other people to make a total of 3 on that committee, right? Now remember, you don't have to show the 1C1s, but in any case, so really it's going to be 6C2 over 14C2. Let's do this one just for the fun of it. Most times we'll say to keep it in fraction form. The odd time in a numeric response, for example, you might be asked to round to a certain decimal place, except for 2 decimal places, that kind of thing.
Oh, what did I do?
Okay. And then last one is deck of cards. You do need to know, you might be asked a question about a card question on Thursday. So a standard deck of 52 cards. Remember, there's 4 suits. So each suit is 13 cards. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King. So a standard deck does not have anything to do with jokers or anything like that. Okay? So, dealt 5 cards from a pack of 52. Order doesn't matter, right? When you play a card game and get 5 cards handed to you, you can switch them around from whatever order, but that's your hand, right? There's no order given to that, unless it's some special game.
Well, I mean, if you're playing, we're drawing 5 cards front and 5 cards draw, and in that case, then it wouldn't matter what order you actually get the cards in.
5 cards, but we're just talking the actual hand.
Okay,
Okay? So, with me, please. So when you look at your 5 cards,
that you're holding, what's the probability expressed in combination notation that you have 4 aces? So, how many aces in a deck? 4. And you want to have, so you want to choose all 4 of them. Do you really need to show that 4C4? Not really, it's a value of 1, right? But you still have one more card to get, right? Because it's a 5-card hand. You've got 4 of them. How many non-aces do you have? 48 to choose your remaining card in your hand. Okay? Total number of possible 5-card hands, 52 cards, and you're choosing 5 of them.
What's the reference? That number is absolutely massive.
Okay? So that's why we're just going to leave it like this.
Every
combination notation.
Every time you shuffle the deck of cards, you're probably encountering a new sequence because, here's gamma particles on the
Okay, next one.
Yeah.
Listening, please. 4 tens and an ace. So kind of similar to the last one. 4 tens is 4C4. It's just that these are for tens, not for aces. 1 ace, there's 4 aces. Oh my gosh. 4 aces, and we're choosing one of those aces. Okay? Out of the total number of possible 5-card hands. Okay? So, that's why you want to be careful of betting and playing cards.
And this call with poker is big different because you also can lie.
Okay, so this, yeah, they're in an order, but they're still in your hand. It doesn't really matter, right? There are 4 tens. So you need to choose one of them. You need to have 1. 4 jacks, you need to choose 1. 4 queens, you need to choose 1. 4 kings, you need to choose 1. And 4 aces, you need to choose 1. So really, that is 4C1 to the exponent 5. Right? Because that's the same thing multiplied together.
My guess is you probably have to put that in brackets because otherwise it would look like 4C51.
Yeah. So you could show it like that if you wanted to. Okay? Need brackets.
Otherwise it'd be like, what is happening?
Okay, and then last one, at least 1 jack. So that would be 1 jack, 2 jacks, 3 jacks, 4 jacks. Can't have more than 4 jacks. Okay? That's a lot of calculations. So let's think about the complement. So this, at least 1 jack, would be 1 minus no jacks. Okay, so there's 4 jacks that you're choosing 0 of them. Do you have to show that? No. How many non-jacks are there? 48 that you have to choose 5 cards in that hand. Right? 0 plus 5 is 5. Over 52 choose 5. All right, so that's where I'm going to leave it. Maybe you did some of those already, but there's lots of practice. The assignment part and the answers are on the next page. Okay, so you can practice those. We'll end it here.